Hello and welcome back to my Blind 75 series. Today we're going to be talking about question number 242, an easy question known as valid anagram. So this problem right here is a super fun problem. I really like this one. It's actually a lot easier than the valid palindrome problem that I went over in another one of my videos. And what's cool about this problem is all you're going to be looking for is to see what an anagram is. An anagram is essentially a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So essentially all that it is that we will be having two strings, S and T, and we will be checking to see if this is an anagram. We are going to be solving this problem using two different approaches. One is going to be sort, and the other one is going to be a hash table. There's a one-liner way to do this, which I'll be showing you as well. I'll be going over the less optimized solution, which is going to be our sorting function, and I'll be going over the more optimized solution, which is going to be our hash table. So, without further ado, please take the time now to subscribe to my channel so that you can see more of these really cool Blind 75 videos. After you've done that, let's go take a closer look at how we're going to be solving this problem. All right, so let's go ahead and take a look at our first example. So our first example, we're going to be using a sort method to be able to solve our problem. And with our sorting method, we're going to get a time of O n log n and a space of O of 1. So this is going to be our less optimized solution. With this solution, we are not going to be as fast because using a sorting algorithm is going to be slower, but this is also a really important solution to keep in mind just because you can literally solve this problem using one line, using the sorted method. So if you are not sure what to do in an interview setting, use your sorted algorithm. They might not like it and be that impressed with it, but it is one way to solve it, and it should be a way that you are able to solve it. I will show you the more optimized version, which is going to be our hash table. You cannot use a set because of the potential of having values deleted, so you have to use a hash table. You cannot use a set. And for our sorting solution, all we're going to be doing is we're just going to take our values and we're just going to sort them and then compare. So if A, G, then we're going to go with M, N, and R, and that's all the values in it, and that's what it would look like if we sorted this. So same thing here. If we look, we have all the same values. We have an A, which we have there. We have another A, an A, one G, one M, one N, and one R. And if we sort that, we should get the exact same thing. So we sorted it, and then all we're going to do is check to see if they're equal. So are they equal? Does this string equal this string? In this case, it does. So we're going to return true. The value that we're looking to return at the end of this is a Boolean. And in this case, so that is our sorted method of solving this problem. But we can one-up that, just like I mentioned before, by using our handy-dandy hash table. And our hash table is a way to solve many of these array and string type problems. And so you should be very familiar with your hash table, and I'm going to go over two different approaches that I like to take. One is actually a one-liner hash table solution, which I love to use because of the simplicity of using it. But what we're going to do here is we're going to go ahead and first make our hash tables. So I'm just going to call this one D1, and then this one is going to be called D2. For both of our string values, all we're going to do is simply just loop through the string and add the values into our hash table. And so when you have a hash table, you can either start your values at 1. So if I'm going to add this first value in, we can start it at 0, or we can start it at 1. And it might depend on how you like to solve these problems. So you can have the first value be 0, you can have 1. It just depends on your preference. But I'm going to start with 1. So right now we have that first A in there, so we're going to cross that off. Now we're at N, so there's no N in there, so it's going to just be 1. Well, now we've reached another A, so we're going to increment our A value to 2. Now we have our G, and G is going to be 1. Then we have R, and R is now going to equal 1. A again. So we're going to increment our A value inside of our hash table by 1, and that's going to equal 3. and then m is going to equal 1, and that's our last value. So we can actually just finish off this dictionary because we have gone through all the values and looped through them. Now we can take a look at our T string, and we're going to do the exact same thing. So we're going to do 1 for n, A is 1, G is also 1, A is 2 because we increment it, R is going to be 1, A gets incremented because we have another A value, and then we have another value which is M, and that completes our dictionary. And then all we're going to do at the end of that is we're just going to see if these two values are equal. Are they equal to each other? Well, we can look at our first value in our D1 table. Is there an A3 value? So is there 3 A's in D2? Yes, so we know that's true. Is there one N value in each table? Yes. Is there one G value in each table? Yes. Is there one R value in each table? Yes. And then lastly, M, yes. So in the end, we're going to return true. And these are our two methods that we're going to use to solve this problem. All right, so we're going to go ahead and go with our first approach, which is our sorted approach. And this is a super difficult way to solve the problem, so I hope that you guys can bear with me. But all we're going to do is we're going to go with return sorted S, which is our first string, equal to sorted T. And that's it. That's the whole solution. So if we run this, we are going to get a faster than 59.44, and it has less space than 6.37. And we can see if we run it again, we might get a little bit of a better score. But as you can see, it's not a super fast solution in any way. This isn't the best way to solve the problem, but this is one way to solve the problem. And it's really cool because it's a one-liner. So that is one way that we can go ahead and solve this problem. Now, the next way that we're going to use to solve this is going to be our hash table. And I have two different ways that I like to create the hash table. And for this specifically, this specific problem, I do like to make a helper function where we create our table because we're going to need to use it twice. And generally in software engineering, you want to take out as much redundancy as possible. So in this situation, because we're going to create two tables, I don't want to have redundant code where I'm creating the hash table for both of them. And one way we can do that is we're going to make our helper function. In order to do that, there's one of two ways that you can solve this problem doing that kind of way. And we can first create our dictionary, then we can create our loop. So for char in string, so string is the variable that we're going to be taking into our function. If char in dict is not in dict, so first we need to make sure that we don't currently have a value in our dictionary, because if we already have that value, then we're going to need increment. That's going to be our else value. So in the situation that there's no value already in there of the string inside of dict, we're going to add that value into it. So dict char is going to equal 1. And as I mentioned before, this is where you would add the 0. Else dict char plus equal 1. So either we are going to make equal to 1 because there's no value for that char currently in our table, or we're going to increment by 1. And at the end, make sure you don't forget to return our dictionary. I have made that mistake way too many times, and make sure you don't forget it because it's super important or else it's not going to work. After that, all we're going to do is we're going to create our tables for our string. So you have to call self when you have a function inside of our class that's not within the other function. So self.createTable for our helper function, and then put our S string in there. And we're going to do the same thing for the T. So T equals self.createTable, create table, and T. And then lastly, all we're going to do is return S table equal to T table. Let's go ahead and submit. And we do get a little bit faster. Let's see if we can actually get a little faster than that. Faster than 93.72% with less space than 54.39. This is one of our faster ways to do this problem, but I do want to show you one more optimization that you can make in terms of just how it looks. Another fun way that we can solve for hash tables is to write it like this. So we'll have dict equals for char in S, and then we use this one-liner right here. So we have our dict char equals 1 plus table dot get that char, and the value is 0. And then at the end, we're just going to return our dict. And if we run this, so if we do something like every time we're just going to print what the dict looks like at the end, we can get an idea of how this kind of looks. We can run this code. Oops, I forgot to make this dict right here. My bad. Let's run that again. And as you can see, it adds both of the string values on. So it starts at 1 right here, plus dict.get char. And this little one-liner is just another way that you can create a hash table with much less lines. I really like it. It's a cool little way to approach the problem, but you're going to get the same exact thing. So instead of writing a big long hash table, remember this right here. And use this when you create hash tables as a one-line way to create them. You will have to still remember your loop. You will still have to remember to return and call the dictionary. But this right here will do the same thing as the other longer version of the function will. So we can submit, and let's see. It should be around the same exact speed because we didn't do anything too different. But we get about the exact same thing as we did before. So this is just another way to solve the problem. And that is actually all I have today for you to be able to solve the is anagram problem. If you enjoyed this video, please take the time now to subscribe to my channel. Really helps me out, and I'm going to be continuing to make this Blind 75 series. Plus, I also want to make some other videos specifically involving some kind of backend programming stuff as well. So if you're interested in learning more about software development and you're interested more in interview prep type videos, take that time now to subscribe so you can see some of more of my upcoming videos. Until next time, good luck on your interviews, good luck in coding, and see you soon. Bye-bye.